Video we are going to discuss about connectivity or hierarchical based clustering. As we know, clustering is about grouping of different objects together. For example, suppose we have these objects, we want to group them into one cluster and another into a different cluster. So this step can be achieved via variety of algorithm. One of those algorithm is hierarchical clustering. So the way it achieves this process is that it creates something called a dendrogram, which is nothing but a tree-like structure. At the leaf nodes, what we have is two of the points, for example, one here, and they have been clubbed together. Similarly, you can pick any leaf and you can see only two nodes are there. So tree is formed using combining these leaf nodes into a greater node, and ultimately into a final root node. So how does it work? So let me explain the basic intuition behind it. So first, what we are going to do is we are going to have a series of nodes. For example, like here it has been mentioned here. So then what we are going to do is we are going to use a distance algorithm to see how much similar these nodes are to each other. So we can use a variety of algorithm for that purpose. The most prominent one are Manhattan, we have Euclidean, we have cosine, or any similarity or dissimilarity matrix can be used here. So at first pass, we are going to compute the Manhattan distance between each and every node with other node. Like for example, if we have 10 nodes, then total distance will be like n minus 1 by 2, which is 10 by 9 by 2. So this is a handshake kind of a thing, like each node is going to do a handshake with other. By handshake we mean computed distance, and then we are going to sort this out, and the nodes which the least amount of distance are going to be clubbed together and they will form a one node. For example, we have 10 nodes, then two nodes will be clubbed together, so now to form one node, and we have now 9 nodes in total. And this step is going to be repeated such that we will have this dendrogram kind of a structure. For example, in the first pass, these two nodes have been clubbed together. So these nodes are here, like B and C, right? So these are here, and E and F has been clubbed together in another pass. For example, they are here, and similarly other, and then they forms a single node. And then once new and like computation has been done, so we notice that the combination of E and F node is similar to D node. So now these have been clubbed together and we form a hierarchical structure. So now the algorithm which I discussed in this phase is called as agglomerated clustering. So similar procedure, like they start in a bottom-up manner. By that I mean is they are going to treat each node as an individual cluster, and then they are going to compute a similarity matrix like has been explained here, and then they are going to link these nodes. Now the linking can be done using a variety of function. We are not going to dive in that. You can just have a look around that, or we can make another video of it. So the linking method which has been used in agglomerated clustering is more like word, complete, average, and single. Each have its own different merit and procedures. So now using linking function, we are going to combine a node like explained here. E and F have been combined and they have formed a different node, and then this process is repeated again and again in a iterative manner. So in a nutshell, this is agglomerated clustering. Now we have another algorithm which is similar to this but different in a manner, which is called the divisive hierarchical clustering. So in that, instead of starting from a bottom-up manner, by that I mean is instead of starting with like individual elements and computed distance, it treats all the elements into a single cluster. Like all these elements are into a single cluster, and it just repeat, like it just follow the same principle of agglomerated clustering but in a reverse manner. The idea is same, just the agglomerated clustering is a bottom up and it's a top down approach. So yeah.